making it go to the right. 2. What does that mean for our vertex? So it would be the point 2, comma, 0. We put that in the middle of our table, and we can go ahead and graph it. Okay, because it moves it, because all of our absolute value functions start at 0, 0, and then the transformations move them. Okay, this one got moved to the right, so it's 2, 0. Now, when we look at this, we can go ahead and we can find what is something smaller than 2?
1.
What is something smaller than 1?
0.
What's something bigger than 2?
3.
Bigger than 3?
4.
So we can take these values and plug them into our equation. So what we can do is we can do the absolute value of 0 minus 2. What is 0 minus 2? What is the absolute value of negative 2? 2. So that is our first point. Okay. So 0, 2. Okay. Then we do the same thing with 1. So we have the absolute value of 1 minus 2. What is 1 minus 2?
1.
And what's the absolute value of negative 1? 1. So that is the point 1, 1. Now that gave us half of our absolute value graph. What do we know about the graph of an absolute value function? It is what? It starts with an S.
Symmetrical.
It is symmetrical. It is symmetric. Okay? Which means it's the same thing on both sides. If I didn't hear you, I'm sorry. Okay? But it is symmetric, which means it's going to be the exact same on both sides. So what does that mean the point at 3 is going to be? It's going to be 3 comma
1.
1. It's going to be symmetric, so it's got to be the same. Okay? And then at 4, it'll be 4 comma 2. Because those two need to be the same, and those two need to be the same. So that way, when we have our graph, it is perfectly symmetrical. Okay? Now, we are going to talk about a few more of these. So on 13. When we look at 13, we're going to talk about another way we can graph these without having to plug it in every single time. Okay? So for this one, we need to first find our transformations. What are our transformations in number 13?
Vertical stretch of 2.
Yep, it is a vertical stretch by 2.
And then down 1.
And it is down 1. Okay, so let's put that in here. Vertical stretch by 2. And it also goes down 1. Does a stretch or shrink or reflection affect your vertex? No. Okay, so that isn't going to affect where our vertex goes, but does going down 1 affect our vertex? Yeah. So what would our vertex be?
0.
0, negative 1. Okay, we can put that in the middle of our table. 0, negative 1. Now, instead of plugging it in, there is another method you can do to help find the graph. Okay, and it's actually using your A. So in this problem, what was our A? 2. So in this problem, that is our A. A also acts like the slope of the sides of the line of V. So if I wanted to graph this, I could just use the fact that our A is 2. And from this point, I could go up 1, 2 over 1. Go up 1, 2 over 1. And that gives me half of what this graph will look like. Okay, so if I wanted to do the same thing on the other, yes ma'am?
If you didn't have the graph, how would you solve that? Would you just plug in the vertex?
What do you mean if I didn't have the graph?
Like, do you have to have the graph to be able to, like, to solve, to get the x and y?
To get the table?
Yeah.
You can use the graph or you can plug in like we've been doing. Either way works. Okay. This is just a slightly quicker way when we have an A. It makes it go a little bit easier. Okay, so if I wanted to get the other side of that, what would I need to do? Yeah, just go the opposite direction, go up 2 and over in the opposite direction. And now we have our full graph. Okay, so when we look at this, we can actually get our points now. Okay, so if we start here, what is this point?
Negative 2, 3.
Mm-hmm. What is this point?
Negative 1, 1.
What is this point?
1, 1.
And what is this point? Okay, so that is another way we can graph the absolute value functions. So we can either plug everything in and start with the table, or we can use A to find the slope of the sides of our V, graph it, then write the points. If it gives you a table to write the points on. Okay, for number 14, okay, what is our transformations? It is left 2. And it is up 1. So what would our vertex be here? Negative 2, comma 1. So we can put that in the middle of our table. Okay, so graph at negative 2, 1. Now this one, do we have a visible A?
Nope.
What is understood to be in front of something if we don't? 1. So that means right here, there is technically a 1. So what does that mean the slope of the sides of the V need to be? 1 over 1. So we're going to go up 1 over 1, put a point. Up 1 over 1, put a point. Then we can do the same thing on the other side.
You only put 2 points.
You can put as many as you want. It's just you need to do at least 2 points on each side. You should have 5 points in total when you do these. Unless it fully runs off the graph, and then I'm okay if you just do 3 points in total. But you should have at least 1 point on either side of the vertex. It's what you have to have on the graph.
So how do you get the vertex?
So the vertex, we get that from our transformations. So by looking inside the function, we get our horizontal transformation. So here, what would you need to plug in right there to make that whole thing 0? Negative 2. So that's where we get the left 2 and the x of our vertex, okay? The plus 1, that is our vertical shift, okay? That gives us the up 1 and the 1 of our vertex, okay? So we get that first, and then we can use A, or we can plug in and make a table and graph, either way. So what is the coordinates of this point? Negative 4, 3. What is the coordinates of this point? This point? And this point? That's supposed to be a negative 1, 2. My bad. I was like, what did I do? What is wrong? Good gracious. All right. So we are now going to look at number 15. Okay. Number 15 is about as complicated as one of these can possibly get. Okay. It has 4 transformations. Okay. So it has the max possible amount of transformations that we can have in one problem. And it also has a fractions. Okay. And we know how we feel when we had to do a lot of things with fractions. We get a little freaked out. Okay. So this type of problem is why I made a point to talk to you about how A is the slope of the sides of the V. Because this problem, when you go and plug in some numbers, it's going to be really weird and you're going to have to add and subtract a bunch of fractions. And most of us do not like to do that. Okay. So let's start with finding our transformations. What does this minus sign at the front do? It will reflect it across the what? All right. What about the 1/2? What does it do? Vertical shrink. Okay, the -2, what does that cause? Right 2. What about the +3? Up 3. So what would our vertex be? Okay, so we graph the point 2, 3. We can put that in the center of our table if we want to. Okay, now what is our A? What is A? -1/2. Our A is -1/2. So that means we're going to go down 1 over 2. Down 1 over 2. That goes off, but we can still kind of show it. Down 1 over 2. Down 1 over 2. Once we do that, we can show the full absolute value function. And then we can write our points. So far, we've only done points that are directly next to the one, right? We can also skip a couple plates. So like, if I wanted to want a point at 1, is that line exactly on a point? No. So it's more like we have to, and that's what I was meaning by our answers being a little weird if we plug in. Because if we plug in 1, we're going to get 2.5. So it's a little weird. So what we can do is if you use A as your slope, you can just put the whole points on there that we find on the graph. What is this point? So we can do -2, 1. What is this point? Okay, then we have 2, 3. What is this point? And then what would that last point be? Here we go. So also today, we're going to do a little bit of practice, okay, with everything we've done from 5-1, okay? So what I did, Unit 5 is shorter than the average unit, right? There's only 3 different sections. It looks longer only because there's graphing problems, and I make the graphs as big as I can, reasonably, just to be able to see them. So what I did was I went ahead and put 5-1 through 5-3's assignments in this one thing. Okay, and I'm just gonna pass it out all at once. It let me send it to print shop and get it done super quick, so I didn't have to worry about it. And we're gonna turn this in at the end of Unit 5, okay? So I'm gonna go ahead and give these out. Yes.
Sit down. You look so dumb, bro. Isn't that a flavor? Oh, this is elementary school.
Got finding your
Elementary
transformation.
school.
Okay, and then once you get your transformation,
I wasn't even doing that. Hey, you never even thought that some of the other stuff you know.
okay, so we're gonna go over. We're gonna go over
tell me right now.
first before you
Is
leave.
this all gonna be one grade? Just that it's all.
No, it'll be 3 separate grades.
Everybody here, they-
That'll be an interesting tactic. Y'all aren't getting your papers. How about that?
All right. So now, okay, we are going to go over a couple things about this assignment before I let y'all work on it. Okay, so Okay, we're gonna start on the first page here, okay? On this first page, we are only going to do questions 1 through 6. So go ahead and put that at the top of your paper. You're only gonna do 1 through 6 on this page. And in addition to graphing these, I want us to also put the vertex and the transformations. Okay, so we're also going to put next to the directions where it says graph each absolute value function, we're going to put find transformations and vertex. Okay. So we're going to do 1 and 2 of these, and then we're going to go ahead and look at the back. Okay. So for question 1, what is the transformation happening on question 1? It is a vertical stretch of 3. Okay. So it's a vertical stretch. By 3. Does a vertical stretch affect the vertex? So what's the vertex? Okay, so we're going to put that point at 0, 0. So 3 is our A. So what does that mean we're going to do for slope? So we're going to go up 3 over 1, up 3 over 1. That's half of our graph. Then we're going to repeat the same thing to make the other side match, to make it symmetric. And that is what our absolute value function looks like. Okay, then we're going to do the same thing for number 2. For number 2, what is that negative sign in the front cause to happen? It will reflect it across the x-axis. Okay, what does the 1/2 cause to happen? It is a vertical shrink. Do either of those things affect the vertex? So what is our vertex? 0, 0. Okay, so we're going to put a point at 0, 0. But negative 1/2 is our A. So what does that mean we need to do for the slope of the sides? Do we need to go up 1 or down 1 because it's negative? So down 1 over 2, down 1 over 2. Draw our graph, and we have our absolute value function. Okay, so that is what we're going to do for questions 1 through 6. Do we have any questions on those? Okay, then we're going to go ahead and flip to the back. It says 5-4 at the top. That is just because this unit, for some reason, split up graphing and transformations completely, like in the actual curriculum, and that's just a little weird because they go together so perfectly. It makes more sense to do them together than to space them out by a week. So that's what the back is. That's why it says 5-4 at the top. It is what we did in 5-1. Okay. So on the back, we are going to do questions 1 through 7. And all we're going to do, okay, this first section, it says verify, or for each function, identify the vertex and the axis of symmetry. We're not going to worry about axis of symmetry, but we are going to do transformations. So go ahead and mark that out and put and transformations. And then we will do one of these together. I guess we'll do number 1 together. Okay, so what transformations are happening in number 1? Down 5. So we're going to put down 5. Then what would our vertex be?
0.
And so that's all we have to do for that. We put our transformation and we put our vertex. Okay? Now, we're going to do the exact same thing and we're going to graph these graphs. This is what we just finished doing in our notes. Okay? So we're going to do number 2 together. Okay? So we're going to describe the transformations and graph it. So we also need to make sure we put our vertex. Okay? Because you have to have that to graph. So for number 5, because that's what we're going to look at. So we're looking at number 5 on the back. What does that minus sign right there cause to happen? It is a reflection across the x-axis. What does 1/2 cause to happen? Vertical shrink. Okay. What does -5 cause to happen? To the right 5. What does +3 cause to happen? So using our transformations, what is our vertex? So we will go to the point 5, 3. Okay, what was our slope for this one? -1/2. So what do we need to do? So that gives us half of our graph. To get the other half, what do we need to do? Down one, go the other way. And now we have the graph of this absolute value function. Do we have any questions on the back? Okay, if you would rather plug in the numbers like we did on the first few questions, you can just draw yourselves a little table. Like that. Just draw yourself a little 5x5 table. Or 2x5 table. 5x2? I don't know. But any questions on that? All right. So you will do questions 1 through 6 on the front and questions 1 through 7 on the back.